Hi there. Today we're going to talk about managing storage in Red Hat 8. This is an essential task for system administrators. Before we start, let's have a quick review of disks versus partitions. The disk is actually the storage device. It's the part you can hold in your hand and that you physically connect to your computer or server. A partition is how your computer views the device in usable chunks. So a disk is the actual physical storage. Partitions are how your computer reads that. To list the physical devices, we use the lsblk list block command. I'm doing this demo on a virtual machine, so the disks are VDA, VDB, VDC, and this represents 3 hard disks attached to the virtual machine, simulating 3 hard disks attached to one computer or one server. If this was a non-virtual computer, you might encounter disk letters like SDA, which is SATA or SCSI, HDA, which is legacy, or even NVMe, which is a newer type of SSD, which is actually significantly faster. There are 2 ways to designate partitions on a disk. We're going to use GUID partition table, which is GPT, as it's a much more modern and useful system. The master boot record, MBR, is a legacy system that should only be used in special cases, but you might find it on older legacy systems. Older servers may have MBR still. In GPT, up to 128 partitions are available with no issues. MBR has only 4 partitions, and then the 4th one is split into logical partitions. And it's just a much more antiquated, older system. But if you find it in a legacy system, it'll probably already be set up. The default tool to manage partitions in RHEL 8 is parted. You run the parted command followed by whatever physical device name you'd like to manage. In our case, we're going to run parted/dev/vdb. Inside parted, it's really helpful to just run help immediately, and that shows you all the commands that are actually available, and there's quite a lot of them. Print shows you how the computer is viewing the device currently. Right now, we have nothing, there's very little metadata about this device. It doesn't even have a label. So let's start with that. The command is mklabel GPT, because we're using GUID partition tables. If you wanted to use MBR for some reason, the command is actually mklabel ms-dos, and that'll give you an indication of just how old MBR is. Next, we're going to make the partition. mkpart is the command, and you can attach a bunch of parameters to mkpart, and it will create the partition if you've put the parameters in correctly. However, it also has an interactive mode, which makes life really easy. So let's just go mkpart, and we'll have to designate the partition name. In our case, it's going to be /data. Then a file system type. This is not the file system that your Linux system will actually be reading. This is only for metadata. I'm going to use XFS simply because I'm using XFS as the actual file system, and you'll see that in a couple moments, but ext2 would be just fine. Then you have to designate where you want to start. In our case, 1 megabyte. And then we have to designate where we want to end. In our case, we're going to use 10 gigabytes. This disk is 50 gigabytes, so 10 gigabytes will fit in there quite nicely. Next, we want to show what we've created. So we do a print, verify that it is actually what we're expecting. Then we'll do a quit. Now we're out of parted. However, the Linux kernel needs to reread the partition tables. So in order to do that, we issue udev_adm --settle. Notice it's not tac settle, it's space settle. Now we're ready to create a file system to go on our newly created partition. Now, file systems in Linux is a huge topic. There are multiple kinds of file systems, and multiple people believe then one file system is much better than a different file system. In this case, we're just going to use XFS. It's the default on RHEL 8. It may not be the default in future versions, but in today's version, XFS is the right version, is the default file system. The first step is to always run ls-block to be sure that we're running it on the correct partition. Then we can look at mkfs, and if you hit tab here, it actually shows you how many file systems are available and supported by RHEL 8. And there are actually many more file systems available. However, these are the ones that are supported by default. We're going to use XFS, mkfs.xfs, and then we're going to use /dev/vdb1, which is the partition we're trying to create a file system on. All right, file system is created, and we're ready to move on to mounting. So mounting a partition in Linux can be done in runtime, and it can be done permanently. Runtime is done as a test to make sure that your system is working, it's doing what you're expected, and once that works properly, then we make it permanent. So the first thing we need to do in order to mount it is give it a place to mount. In our case, we're going to make a directory called data, mkdir/data. It can be anywhere in the file system hierarchy. It doesn't really matter where you put it, as long as you know where that is going. And then you simply mount with the command mount /dev/vdb1 and then space /data. And that's it. It's mounted immediately. If you type in the command mount alone, you will see, usually the very last one, the file system that you just created is now available and ready to use. If you want to navigate there, you can create files, etc. It will work. This is only in runtime. That means if you were to reboot your system, if something had gone wrong in this process and you rebooted your system, it's gone and you have no worries. You've not mounted it permanently, you've not wrecked your system. Once you've tested it and it works and everything is going as well as you want to permanently mount this system. Otherwise, if this server gets reset in the middle of the night or whatever, and you're not around immediately, or even if you are around but it's 3 years later, your file system is going to be gone. It could be having a database that is important. It could have multiple different things on it that are just critical to your system. And if it's gone, nobody's going to know where it went. So we want to make it a permanent mount. In order to do that, we do this in etc fs tab. So we need to edit it using vi or vim or whatever. In here, you just go to the bottom of the file, create a new line. You want your device name, and then a file system location, where it's going to actually be mounted in the file system hierarchy. And then the file system type, in our case, it's XFS. And then finally, just add defaults, 0, 0. And those are more advanced storage parameters that we don't need to worry about for this video anyways. At this point, if you reboot your system, your partition will show up again. So you've expanded the storage on your computer. So let's go ahead and do that. We'll do a reboot. We'll log in, and immediately you should see /dev/vdb1 will be in the list of file systems that are available and usable by Linux. Okay, thanks for watching. In the next video, we're going to talk about much more advanced storage systems like logical volume management, LVM, and Red Hat 8 is creating Stratus, or has created Stratus, which is another logical volume manager. We'll talk about those, but first we needed to talk about the basics of how to add a disk to your server. So we've done that. Look forward to the next video, advanced storage. Thanks for watching.